Hi! Today we're going to learn about the radius of convergence in calculus. Let's say we have a problem like this. Compute the radius of convergence of the series from n equals 1 to infinity of x plus 5 to the n power over e to the n power. So how do we do that? Well, let's think about all the tests that we know. Now, the main one that we know is the ratio test. And the ratio test tells us whether a series converges or diverges. Now the ratio test is most useful when there are different rates in the numerator and the denominator. So in the numerator we can see we have x plus 5 to the n power, and the denominator we can see that we have e to the n power. So those are sort of different, but the main rate part is the to the n power. But we can still apply the ratio test. So let's go over what the ratio test is. So the ratio test is L is equal to the limit from as n approaches infinity of a sub k plus 1 over a sub k. Now if L is greater than 1, then it's divergent. If L is less than 1, then it's convergent. And if L is equal to 1, then the test is inconclusive. And you have to figure out another way to figure out whether it converges or diverges. So why would we use a ratio test when we're trying to figure out what the radius of convergence is? And before we even do this, let's first go over what the radius of convergence is. So the radius of convergence is basically the radius of, or it's the so there are some values that we plug in for x that make the series converge, and there would be some values that if we plugged in for x would make the series diverge. So we see that we have this interval from a to b, where a and b may or may not make this series converge. We see that we have this interval from a to b, and all these values inside this interval or outside the interval, but there is an interval where the series converges. So this is called the interval of convergence. So this is called the interval of convergence. So if we plug in any of these values into the series, then the series converges. If we plug them in for x, not for n. So what is the radius of convergence? So the interval always has to have a center because it's a finite thing. So there's always a center for the interval. And that means that the radius is basically the distance from the center to one of the endpoints. So this would be the radius. So that's what the radius of convergence is. It's basically the distance from the center that whatever value is, if any value is smaller, if the distance from any value to the center is smaller than the radius of convergence, or is equal to the radius of convergence, or is smaller than the radius of convergence, then if we plug that in for x, then it converges. However, if it's equal to the radius of convergence, then it may or may not converge, and you have to test that. And if it's greater than the radius of convergence, then it does not converge. So let's do this problem to get a greater understanding of this. So let's use the ratio test. The ratio test says we get the limit as n approaches infinity for the absolute value of x plus 5 to the n plus 1 power over e to the n plus 1 power times e to the n power over x plus 5 to the n power. So we can simplify whatever's in this limit here. That becomes the limit as n approaches infinity of the absolute value of, so we can use exponent rules. So we get x plus 5 and x plus 5 are the same base. So we get x plus 5 to the n plus 1 power minus n, which is just x plus 5 to the first power, over, so here now we have e as the same base, so we get e to the n power minus, so we get e to the n minus n plus 1 power, where n plus 1 is in parentheses. So this is e to the minus n plus 1, which is the same thing as e to the negative first power. So e to the negative first power in the numerator is the same thing as e to the first power in the denominator. Now we can see that these are all constants. So in this example, x is a constant because we plug the value in and then we see if the series is convergent. So here we know that these are all constants, so we can pull it out of the limit. Or we can just say that because there is no n in here, the limit is equal to this. So this is equal to, the limit is equal to the absolute value of x plus 5 over e. So we came out with something that had an x in it. And this is what we want, because we want some value that has an x in it so that we can figure out for what values of x L is convergent. L is less than 1, so that we can figure out for what values of x this series converges. But how do we do the next step? So we did the ratio test, and we get this is equal to L. But how do we figure out whether L, or when L is convergent? Well, we have to set this to be less than 1. So we know that if L is less than 1, then it's convergent. Now if we set this less than 1, then that means that x plus 5 over e is less than 1, but it's greater than negative 1. So we're sort of getting an interval here. Now we have to figure out what x is, or the interval for x. So we multiply both sides by e, giving us that x plus 5 is less than e, but greater than negative e. And I'll move up so you can see how we get there. And now the final step is subtracting 5 from both sides. That gives us that x is less than e minus 5, but greater than negative e minus 5. Negative e minus 5. So now what do? We have this interval here. Now if we remember that picture that we drew in the beginning, we can figure out what the radius of convergence is. So we have this interval, and we know that the radius is the distance from the center of the interval to one of the endpoints. So let's figure out what the center was. How do we figure out what the center was? Well, the center is the value that we plug in for x that makes this equal to 0. That value would be negative 5, because if we plugged in negative 5 to this, we get 0 to the n power over e to the n power, which is 0. So the center is equal to 0. So the center is at x equals 0. But there is another way of doing this. We know, so let's draw that interval picture again. We have A, the interval, and B. We have the center point, and this is R. So if this is the radius, then that means that the distance from A to B should be the diameter, not diameter. Meaning that if we took this distance and divided it by 2, we would get the radius. So let's do that. Because let's say that we couldn't find the center, so how else would we do it? So let's do that. So we get the distance, and take a moment to go over this because now I have to erase it. So we get the diameter, not distance, the diameter, which is equal to this interval, or the length of this interval, is e minus 5 minus negative e minus 5. So this would be equal to e minus negative e is 2e minus 5 plus 5, because we have minus negative 5, is equal to 0, giving us that the diameter is 2e, meaning that the radius equals e. So the answer to this problem is the radius of convergence is e. Today we learned about the radius of convergence. Thank you for watching this problem, or thank you for watching this video.